Hello, and thank you for joining me. You're here with data science teacher Brandon, and today we're going to look at the pairgrid. Pairgrid is a little bit more of a complex version, allows a little bit more flexibility than the pairplot. So pairplot is great, it's amazing. You can do so many plots so easily and so quickly, but it's a mirror image on one side and the other. And then that can be interesting to look at sometimes, but I feel that we can make a little bit better use of this shelf space. So great plot. Pairgrid works a little, I tend to use Pairgrid a little bit more because it's a little bit handier. You can control the upper and lower quadrant. Okay. So you call it SNS dot pairgrid and it's a class. And this specifically means in our case that we're going to make sure that it's a capital letter. So P for pair, G for grid signifies as a class. Don't worry so much about that right now. We're going to work with it just as if it were a function. Okay. So G equals SNS dot pair grid. We're giving it our data frame, and it's going to plot all of the numeric features by the bivariate plot of each of those. We're going to then, after we've assigned it to an object, so our seaborn pair grid object, we're going to call dot map underscore diag, and we're going to put in a univariate plot here. So sns.kde plot, and that will plot across the diagonal where we're plotting the univariate analysis. Okay, we'll call map underscore upper and map dot lower map underscore lower on our pairgrid object, and we'll do the two bivariate plots here. And then and just notice here that I am putting in an argument to regplot. So these are just notice you're not putting parentheses after any of these functions. These are references to these functions. And so up map underscore upper and map underscore lower are going to pass scatter keywords to this argument for regplot. It's going to pass it to this. And so you're just putting it here as another argument in map.upper, and we'll map it to the regplot for you. And then I'm passing it alpha and S for the scatter plot version to get kind of thin it out a little bit, make the dots a little bit. I think it looks kind of interesting like this. And you can really see where the data is. And you can see there's a tail over here, and we have a little bit spraying over here. And this one is very, very tight. And you also have the density, really helps you see that. And you can see that the correlation here, it does look like it from this density plot. And here we can see it's a very tight correlation. Even having the density kind of almost hides it a little bit, how tight it really truthfully is. Okay. So we can use the seaborn hue argument with pairgrid, which fantastic argument in seaborn. This is really one of the reasons you want to use seaborn. So again, assigning our pairgrid to an object. So G, and then we're going to map our up map diag, and then univariate analysis here on our diagonal. Our upper and our lower, we'll do line plot and KDE to map those bivariate plots here. And we're starting to get a lot of texture. You can really see the separation when it happens between the math score and the writing score and the reading score. Really, it would be the math score that's separating these, because we see that the reading score and the writing score, they're almost perfectly correlated between these two different categories, these classes. And so this would be in the gender, the female and male. You can really see that math is really where they are different between those two. Okay. And we can see that echoes in the density plot, the kernel density estimation plot. Okay. Here we're going to call seaborn.pairgrid, giving again the whole data frame, the hue argument gender, and we're assigning that to G. So we do the hue argument in the first initial pairgrid. Okay. Or first initial call of the pairgrid. Map diagonal, we're going to do a swarm plot. I think it looks really good. One of the things to really think about why you would want to use a pair plot or a pair grid is because there's too much. You can't really focus on one little thing. So it's, can I notice things from almost a distance? Can I look at a whole bunch of stuff going on, and does anything catch my eye? Can I see some patterns? Human eyes are really great at detecting patterns, and this is a great way to kind of use the thing that humans are good at, is really seeing those patterns that are from a distance. Here you can see there's some bluer on the low side here. What I did was swarm plot across diagonal, and you can see with a swarm plot, you can see where there is and where there is not data, where there might be little patterns in the bunching up or crunching of data. Here you see there's a whole bunch on the lower end. You see how thin, very, very thin trickle of where the data is up here. And so could that be patterns? Does that relate to something else? And these can be something that you can see very quickly and easily, kind of from a distance, using this using pairgrid, but swarmplot works really good here as well. And then looking at the residual plots as well, just to see if with these correlations, if the residuals have any pattern, because residuals shouldn't really see a pattern. It might mean something else, something extra is going on that we're not seeing quite right away. And so here you can see actually, I would say not exactly a pattern, but maybe a hint of a pattern, is that there is a bunching up, but there's a lot of blue on the right hand side of on the writing scores on the upper side, but writing scores by reading scores, when those are both higher, it tends to be one category versus the other. Now this would be very interesting to inspect and really understand a little bit better. It's something that you could see here instantly with the regressions. Kind of hides that there is more blue here when you really closely look at that, but you wouldn't have seen that without the residual plot. It's kind of nice seeing those two next to each other, and then again, pairplot, pairgrid are really about stepping back and seeing if you notice anything, and then you would then inspect that area more detail. This is not kind of your final plot. This is kind of looking at everything very quickly to help you and find out what you should investigate next. Okay, thank you for joining me.